Here's another integral problem where I will use some trig substitutions in the problem. So now I have the integral of 1 over x squared, and in the denominator, this times the square root of x squared plus 4 dx. So in the square root, under the square root sign, I have x squared plus 4. This is of the form x squared plus a squared, where a equals 2. So the trig substitution I want to use is x equals 2 tangent theta. Then you have to figure out what dx is. Well, dx, that's dx over d theta is the derivative with respect to theta. The derivative of tangent theta is secant squared theta. So dx over d theta is 2 secant squared theta. That means dx is 2 secant squared theta d theta. Let's get the substitutions into this problem. I'll have the integral of 1 over, well, x is 2 tangent theta, so that's 2 tangent theta squared times the square root of 2 tangent theta, that whole thing squared plus 4. All of that is under the square root sign. And for this problem, I'm going to go ahead and put the dx in the numerator. 2 secant squared theta d theta, so I had to put dx in terms of theta. And I will start simplifying this problem. So I'm going to have the integral of 1 over, well, I'll have 4 tangent squared theta, and then times the square root of 4 tangent squared theta plus 4. Well, and in the numerator, I'll have 2 secant squared theta d theta. I could have left that 1 times that off. In the denominator, under the square root sign, I'm going to factor out a 4. So this will be the integral of 2 secant squared theta d theta over 4 tangent squared theta times, this will be the square root of 4, that's the square root of 4 that I factored out, times the square root of tangent squared theta plus 1. The square root of 4 is 2. That 2 will reduce with the 2 in the top, or you could reduce the 2 over 4, but you can only reduce one of them since it's all multiplication there on the bottom. Here, I'm going to write a few more steps before I deal with reducing those 2's. So in the bottom, this will be 4 tangent squared theta times 2 from the square root of 4, and then that's times the square root of tangent squared theta plus 1. Now there is a trig identity for that. Tangent squared theta plus 1 is secant squared theta. The square root of secant squared theta will be secant theta. So I'm going to just write this on the side here. This will be the integral of 2 secant squared theta d theta. Now in the denominator, I will multiply the 4 times 2. So that'll give me 8 tangent squared theta times secant theta. Now let's reduce. The 2 reduces with the 8 to give me a 4 in the denominator. The secant theta in the bottom will reduce with one of them in the top to give me secant theta in the top. So this now gives me secant theta d theta over tangent squared theta. And let's not forget the 4. 4 tangent squared theta. At this point, I'm going to change it all to sines and cosines. And sometimes if you're just not sure what step to go with next, that's a good thing to try. Change it to sines and cosines. So I'm going to factor out the 4 for that, 1/4 in the front. And I'm going to have secant theta times 1 over tangent squared theta. Before I change it to sines and cosines, I want to make sure that I keep everything straight. So now tangent squared theta, since that's 1 over tangent squared theta, I could write that as cotangent squared theta. So this integral is 1/4 the integral of secant theta times cotangent squared theta d theta. Now, secant theta, that's 1 over cosine theta. And cotangent squared theta, that's cosine squared theta over sine squared theta. So I will have the integral, let's put in 1/4. 1/4 the integral of 1 over cosine theta times cosine squared theta over sine squared theta d theta. And if I reduce this, I can reduce this cosine theta on the bottom with one of these on the top. So I will end up with 1/4 times the integral of 1 over sine squared theta times cosine theta d theta. And I'm going to rewrite that at the top of the next page. So at this point we have 1/4 times the integral of 1 over sine squared theta times cosine theta d theta. This is now a U substitution problem. And I can say that U equals sine theta, and then the derivative of U, the derivative of sine, is cosine. Du is cosine theta d theta. So now I can say this is 1/4 times the integral of 1 over U squared du. I prefer to write this as 1/4 times the integral of u to the minus 2 du, so that when I do the antiderivative, I'm less likely to make a mistake. So I'm ready to do the antiderivative. The antiderivative u to the minus 2. Add 1 to negative 2, and that'll be u to the negative 1. Then divide by the negative 1. Put on the plus c. So there's the antiderivative. I'm going to write it as, now let's see, this negative 1 that's in the bottom, I can multiply that with 1/4. That gives me negative 1/4 right there. So negative 1/4. And this u to the minus 1 would be 1 over u to the positive 1 plus c. At this point, I've got to go back to theta, and then I've got to go back to x. So first we'll go back to theta. U equals sine theta, so I'll have negative 1/4 times 1 over sine theta plus c. And maybe I want to say that's negative 1/4 times cosecant theta plus c. since 1 over sine theta, that's equal to cosecant theta. Now I've got to go back and recall the trig substitution we had done on this problem, and it was x equals 2 tangent theta. So that is x over 2 equals tangent theta, and I will draw the right triangle for this, put in the right angle, put angle theta, and tangent is opposite over adjacent. So I'm looking at this fraction right here. Opposite is x, adjacent is the 2. And to get the third side, you can use the Pythagorean Theorem. And if I call the third side D, I'm trying to use letters I haven't used in the problem yet, so I'll call it D. Let's see, 2 squared plus x squared equals d squared. So D will be the square root of 4 plus x squared. And so I'm looking, let me write that in here, the square root of 4 plus x squared. And I have cosecant theta. Okay, cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. So cosecant will be hypotenuse over opposite. So I'll have negative 1/4 times the square root of 4 plus x squared, hypotenuse over opposite, plus c. And there's my final answer. If you like, you could clean it up a little bit. Negative square root 4 plus x squared over 4x plus c. Either of those is fine.